All right. In problem number one, you're asked which diagram is not a function, represents not a function, and explain why. So pretty much you have three mappings, A, B, and C, and you have to determine which one of those is not a function. So by looking at that, which one would not be a function? It would have to be C. So graph C is not a function, and what would be a reason that C is not a function? Well, you got -4. It's going to two different y values, 1 and 3. Okay? So you can say something like this, like -4 is paired 3. Okay? That would be a reason for saying that mapping C is not a function. Are there any questions about number one? All right, number two is to use the vertical line test to determine if the graph below represents a function. So in this case, let's say we had a graph that looked like this. And I want to use that vertical line test to determine whether or not it is a function. Would this be a function? No, would not. Because if I draw that vertical line through that graph, if I draw the vertical line through the graph, you're going to see that this graph, or that vertical line, crosses the graph at two different places. So that means that this graph would not be a function. So this one is not a function. All right. Are there any questions on number two? All right, number three. Says here for the function f of x equals to 3x cubed plus 5x squared, we want to find f of -4. So here we have f of x is equal to 3x cubed plus 5x squared. And we're going to find the value of this function when x is -4. So f of -4. So pretty much all we're doing there is just substituting each x in that function with -4. So here we're going to have 3 times, and x is -4, and that's cubed, plus 5 times x, which is -4, and that's squared. Now, when you cube a negative, that's going to be negative, so I have 3 times, and then -4 cubed will be -4 times -4 times -4. That would be -64. And then -4 squared would be -4 times -4, or 16. And then 3 times -64, I think that's -192, plus 5 times 16, which is 80. And then what's -192 plus 80? -112. So the value of this function when x is equal to -4 would be negative 112. Are there any questions about number 3? Right, number 4. Now here we got g of x is equal to x squared plus 2x plus 3, and we're going to find out what g of x plus 5 will be. So here g of x is equal to x squared plus 2x plus 3. Want to know what g of x plus 5 is going to be. All right, in this case, for every x, we replace it with the x plus 5. So x squared, that x will be x plus 5. And that's going to be squared plus 2 times the x, which is replaced with x plus 5, and then plus 3. Okay, so now let's simplify this. For that x plus 5 quantity square, now I'm going to do this off to the side, because x plus 5 quantity squared, that means that x plus 5 is used as a factor 2 times. So I'm going to write x plus 5 twice as x plus 5 times x plus 5, and then apply the FOIL method. So in this case here, if I do x times x, x squared, the outer, x times a plus 5 plus 5x, the inner, plus 5x, and then plus 25. Combine like terms here, you're going to have x squared plus 10x plus 25. That's what x plus 5 quantity squared would be. And then distribute the 2 over the x plus 5. 2 times x, that's a plus 2x. And then plus 2 times 5 will be 10. Bring down that plus 3. Now let's combine some like terms here. Bring down the x squared. Now it's 10x plus 2x. 12x. 25, 38. 25 plus 10, that's 35. 35 plus 3 will be 38. So for g of x plus 5, I get x squared plus 12x plus 38. And it's just going to be an algebraic expression. Yeah. A one-page sheet of notes is allowed, just like the last test. Any questions on number 4? All right, number 5. Here you're going to use this graph to determine these 3 things. In part A, you're going to find the open intervals on which the function is increasing, if any, and the open intervals on which the function is decreasing, if any, and the open intervals on which the function is constant, if any. So here we have this graph right here. So in part A, we want to find out where it is increasing. And your answers will be in interval notation, by the way, I should say. So if I cover the piece of paper over the graph and move it from left to right, here you can see that the arrow, this continues on to negative infinity, so we know it's going upwards so as we go from left to right, so it is increasing. Yeah, negative 4. From negative infinity to negative 4, the graph of this function is increasing. So I'm going to say increasing on infinity up to negative 4. Okay, let's see, part B is also decreasing. Because after -4, it starts to decrease, then decrease, and then it reaches its lowest point at what x value? So between -4 and -3, the graph that's decreasing. Notice we're only using parentheses, not brackets. Okay. Okay. Because at 4, it reaches its highest point. So we don't include brackets. We use parentheses. Any other questions? And then after -4, it increases again. -3 up to -2. And I'll put commas here if you want to. -3 up to -2 is increasing. And then after -2,
It's still negative. No. Would it be a negative?
it's still going
So it be positive infinity?
positive infinity. Okay? So those, and constant, nowhere. So in part C, you can just say none. Just say none. Questions on number 5. Number 6 on the next page. Here we're given the graph of the function f of x. And we're going to use the graph to find each of the following. We're going to find the numbers, if any, at which f has a relative maximum. And then what are these relative maxima? And then part B is finding the numbers, if any, on which it has a relative minimum. And what would be the relative minima? Okay, so first of all, we have to find out what the x values where the relative maximum occurs.
-2.
Well, that's your relative maximum.
Oh,
But what's the x value?
minimum? Oh, 2 is at 0.
Look carefully.
Oh, that's -1.
-1. I know that graph is not as clear as I want it to be, but you can see, here's your relative maximum. It occurs at x equals -1. Okay, so in this case here, a relative maximum occurs at x equals -1. And of course, I think we already said what the relative maximum was. It was the y value. It's 2. Okay, so your relative maximum, you're looking at your y value. And in this case, it's at 2. That's the highest y value there for that graph. So that's part A.
So, so we're putting 2 answers down.
Yeah, because the the values, you're looking for the x value where the relative maximum occurs. And then you're going to find out what that relative maximum is, which is your y value. Okay, so that's why there are 2 answers. Where it occurs, the x value, where that relative maximum occurs, and what the relative maximum is. Any other questions? Relative minimum. Just -2. Oh, you're right, it is -2. So we know the relative minimum is -2. Okay, because that's the lowest point on the graph at -2. Okay, so what do the what are the x values where that relative minimum occurs? -2, and what else? At 0.
So it's two of them.
There are two of them. Okay. So the relative minimum occurs at x equals -2 and at x equals 0. Are there any questions about problem number 6? Right, number 7. Here you have a piecewise function, f of x is equal to, now here we use the -2x plus 3 only if your x value is less than or equal to 4. We only use the 3x if the x value is between -4 and 7, 4 and 7. In other words, 4 has to be less than x and less than or equal to 7. And also 5 if x is greater than 7. So using that piecewise function, we're going to find out what f of 4 would be. Yeah, it's less than or equal to 4. So it's equal to, so we have to use a -2x plus 3. So it'd be -2 times 4 plus 3. And -2 times 4 would be -8, and -8 plus 3 is -5. So the value of that piecewise function when x is equal to 4 would be -5.
To always remember the negatives, like to always not forget the negatives. No, not like when you work the problems. Just with any problem, not that problem.
Well,
You just have to just remember.
there's some things you just have to know those rules for adding and subtracting integers. Because when you're adding two integers with like signs, that's pretty much adding and keeping the same sign. But if you add two integers with different signs, you have to subtract and take the sign of the larger absolute value. And here 8 is larger and it's negative, so the answer has to be negative. Okay. Any other questions? Now what about f of 234? So what's f of 234?
X greater than 7. It just be 5.
It'd just be 5.
You don't, okay.
No, because there's no x value, there's no x in the 5 for you to substitute. Any questions on number 7? Okay, number 8. Is to determine if the function f of x is equal to 3x cubed, 6x plus 1 is even, odd, or neither. So anytime you're determining whether you have an even or an odd function, or it could be neither, we replace each x with -x. So here, f of -x, replace that. So it'll be 3 times -x, and that's cubed, minus 6 times x, which is -x. We replace that, and then plus 1. Now, for it to be even, you must get the original function that you started off with. For it to be odd, each and every single term in that function has to change to the opposite sign. Otherwise, it's neither. And in this case, if I cube a negative, it's going to be -3, and then that x will be to the 3rd power. Minus 6 times -x will be a plus 6x plus 1. Now compare that to f of x.
Every one of the change.
Only the
Except
first,
for the one.
except for the first, that plus 1. So would that be even, odd, or neither? It's to be neither. Because the first two terms change sign. That last term, which is the plus 1, remain the same. Every single term must change to the opposite sign in order for you to have a odd function. Questions on number 8? All right, number 9. Here we're going to find the domain of the function. F of x is equal to, here we got 2x cubed plus 9x squared plus 7x minus 4. That whole thing is divided by x squared plus 4x minus 12. And here I want to find the domain of that function.
So we only take
Yeah. Here we're going to take the denominator, since it's a rational function, set that equal to 0, because we want to find out what values of x that would give us a 0 in the denominator. So I'm going to take x squared plus 4x minus 12, set that equal to 0. Now here we got a quadratic equation. Now I'm going to try to factor this into two binomials here. So here that x squared breaks up as x and x. Now what factors of negative 12 gives me 4x as a middle term? 6 and 2. But since one of them is a plus, the other one is minus, the larger of the two factors have to take the sign of that middle term. So the 6 has to be plus, the 2 has to be minus. So I have x plus 6 times x minus 2 equal to 0. And then we set each binomial factor equal to 0. So this means x plus 6 is equal to 0, and x minus 2 is equal to 0. And each one of these we're going to solve for x. So for the x plus 6 equals 0, x equals negative 6. Or for the x minus 2 is equal to 0, x equals 2. So I know at negative 6 and at positive 2, I would get a 0 in the denominator. Now, on the test, you will be required to give your answer or the domain using interval notation. So if this helps, you can draw a number line. See, negative 6 is over here. 2 will be over here to the right of 0. And at negative 6 and negative 2, I'm going to be drawing parentheses because we know, because I know I'll get zeros in the denominator. Any x value less than negative 6 satisfy that rational function. Any x value between negative 6 and 2 would satisfy that rational function. And any x value bigger than 2 will satisfy that rational function. So domain going from left to right, negative infinity to negative 6 to 2, and 2 to infinity. Okay. So that would be the domain of that rational function. Any questions on number 9? All right, number 10. This time we have a function that is a radical function. So here we got f of x is equal to the square root of 84 minus 6x. And I want to find the domain of that radical function. Now with this one, you want to take what's underneath that radical, set it to be greater than or equal to 0, because you want to find out what values of x where you're not going to be able to take, where you can only take the square root of a positive number, because we know we can't take the square root of a negative number. So I'm going to take that 84 minus 6x, set it to be greater than or equal to 0. Okay? So now I'm going to get negative 6x by itself. So I need to minus 84 on both sides, so subtract 84. So it'd be negative 6x is greater than or equal to negative 84. And then if I divide both sides of this inequality by negative 6, we flip this inequality symbol from greater than or equal to less than or equal to. 84 divided by negative 6. 14. Okay. So any x value less than 14 would satisfy that radical function. Okay. And again, you'll be required to give that answer or your domain in using interval notation. Let's see, 0, 14 is going somewhere over here. Now, do we use a bracket or parentheses? Bracket, because it does include 14. And any x value less than 14 would work. So the domain of that radical function, negative infinity to 14, interval notation for that is written like that with the bracket. All right, questions on number 10. Okay, number 11 deals with the sum, the difference, the product, and the quotient of two functions, f and g. And here we are given that f of x is equal to 2x minus 25. G of x is equal to 3x plus 7. And in part A, we're finding f plus g of x. So we're finding the sum of these two functions together. So this is f of x plus g of x. And here we just replace the f of x with 2x minus 25 plus replace the g of x with 3x plus 7. And from there, we just go ahead and combine like terms here. 2x and 3x is 5x minus 25 and a plus 7, negative 18. So the sum of f and g of x will just be 5x minus 18. All right, questions on part A. All right, part B is just f minus g of x. That's the difference of the two functions. So f minus g of x would just simply be f of x minus g of x. F of x minus g of x. So here, f of x is at 2x minus 25. Now, g of x has to be put in parentheses. That's because you're subtracting the entire g of x function from f of x. So now, what's going to happen here is that minus sign will make the 3x, negative 3x, and the minus sign makes a plus 7, minus 7. And now we can combine like terms. 2x minus 3x, negative x, and negative 25 minus 7, minus 32. So f minus g of x will be negative x minus 32. Okay. Any questions on part B? All right, now part C, f times g of x. That's a product of the two functions. So here, we're just going to multiply f of x and g of x. So here we're going to multiply 2x minus 25 times 3x plus 7. So here we're multiplying two binomials, so that means we'll have to use the FOIL method. And that's this, 2x times 3x, which will be 6x squared. The outer would be 2x times the plus 7, plus 14x. And then the inner will be minus 25 times 3x, right? Negative 75x. And then minus 25 times that plus 7. Then when we combine like terms, we're going to have 6x squared. 14x minus 75x will be negative 61x, and then minus 175. So the product of f and g would be 6x squared minus 61x minus 175. Okay. Any questions on part C? Now, part D is just a quotient. Now, I think this one's going to be the easiest one to do because there's not much simplifying that you're going to be able to do here on this one. So f over g of x means f of x divided by g of x. So in this case here, your f of x is at 2x minus 25 divided by g of x, which is 3x plus 7. And I would go no further than that, because I can't factor anything out in the numerator and the denominator to divide out common factors. So we'll leave it as 2x minus 25 divided by 3x plus 7. All right, any questions on number 11? And make sure that you do try to get points on this one, because in the past I've seen students turn test papers in where they have the sum, the difference, product, and the quotient. They had that answer, that question blank. So make sure you get that one. All right, number 12. This one's the composition of two functions. So here we got f of x is equal to 5x minus 23, and we got g of x is equal to 4x minus 1. Here we want to find in part A. Yeah. Some people call it fog, which is actually the composition of f with g of x. And the other one they call it GOP, the composition of g with f of x. We'll start with the composition of f with g of x first, which means this if you write it using this notation, f of g of x, meaning that the g of x function is the inside function, f of x is the outside function. And in this case, my inside function is g of x, but g of x is equal to 4x minus 1. So I'll replace g of x with what is equal to 4x minus 1. So I'm going to be evaluating f of 4x minus 1. Now my f of x, of course, is equal to 5x minus 23. F of x equals to 5x minus 23. So for every x in f of x, I'm going to substitute it with what g of x is equal to. So that means here, in this f of x notation, that x will be substituted with what g of x is. That's the 4x minus 1. And in that 5x minus 1, that x will be substituted with what, 4x minus 1, because that's what g of x is. So I have 5 times the quantity 4x minus 1, and then minus 23. Now let's simplify this side here. Distribute the 5 over the 4x minus 1, you'll get 20x minus 5. Bring down the minus 23. And then you'll have 20x. What's minus 5 minus 23? Negative 28. So it'd be 20x minus 28. So this represents what the composition of f with g of x will be. 20x minus 28. Okay. Thank you very much. And you're right. So let me correct all of this. Let's be plus, plus, plus. So 5 times 1, that would be a plus 5. Now 5 minus 23. Negative 18, so it would be 20x minus 18. So the composition of f with g of x will be 20x minus 18. Okay. Questions on part A. Now part B is the composition of g with f of x. Composition of g with f of x, which means this, g of f of x. And now my inside function is f of x. The g of x is my outside function. So f of x is at 5x minus 23. So I'll replace the f of x with that 5x minus 23. So I'm going to find out what g of 5x minus 23 is. Here, g of x is equal to 4x plus 1. So for every x in g of x, I'm going to substitute it with what f of x is. So in the g of x notation, that x will be replaced with f of x, which is 5x minus 23. And in the 4x plus 1, that x will be replaced with f of x, which is 5x minus 23. So if I distribute the 4 over the 5x minus 23, I would get 20x minus 92. Okay. And then if I bring that 20x down, negative 92 plus 1 will be, so the composition of g with f of x is equal to 20x minus 91. Okay. Any questions about problem number 12? Problem number 13. Now here we're given a composed function. We're going to break it apart. That means decompose the function to find out what f of x and g of x were to begin with. All right, so in this case here, we got the composition of f with g of x. That's equal to 5 divided by the quantity x squared minus 3x plus 6 raised to the 6. And we want to find out what f of x was and what g of x was to begin with. So you have to find out what those were to begin with. First of all, let's find out what g of x is. Because of the fact that g of x is the inside function and f of x is the outside function, so we have to replace the x in our f of x function with what g of x is. And I would say that x squared minus 3x plus 6, that might have been put in place of x. So that would be what g of x is. Squared minus 3x plus 6. And for the f of x, since the x in the f of x function was replaced with what g of x is, that f of x function had to start off as 5 divided by x raised to the 6th power. That's all there is to it. All right, questions on number 13?
So they will all be just as simple, taking what they.
Yeah. Or what's underneath the radical. Okay, because you might have a radical function. What's underneath that radical will be what g of x is, and then f of x will be, of course, yes. Because of the fact that that x squared minus 3x plus 6 had to be put in place of x in the f of x function, it had to start off as 5 divided by, and then the x raised to that 6th power. Okay. And you can check by replacing this x with that x squared minus 3x plus 6, and you should get this back. All right, any other questions?
Can you give an example of a radical?
I can.
Thank you.
So let's say the 7th root of just making this up.
Oh, so the f of x would be the second radical with the x under it, right?
Yeah.
Okay, I remember.
Okay, because see, the g of x is going to be underneath the radical.
Got it, okay.
So that means here, g of x is that 5x squared minus 3x plus 2 And in this case here, this was put in place of x, so f of x had to start off as the seventh root of
And then with the X on it.
x underneath it. All right, any other questions? All right, number 14. Here we're finding the inverse of a function. Okay. So the first step would be to take that f of x, replace it with y. So it'd be y is equal to 9x plus 23. And then the next step would be to interchange x and y. So that means this y would be x equal to 9 times the x becomes y plus 23. Okay, we'll solve for y by subtracting 23 on both sides. Left side would just be x minus 23. Is equal to 9y. And then to solve for y, we just divide both sides by 9. So that means y is equal to x minus 23 divided by 9.
But you have to put it in that F negative.
Yeah.
How do you say that?
F inverse.
F inverse.
F inverse of x to that, x minus 23, all divided by 9. All right, questions on number 14. And finally, number 15 is using the horizontal line test to determine if the graph below is an inverse. And believe it or not, I get people that miss this question as well. And it says use the horizontal line test. Some people draw on that vertical line to determine whether or not it has an inverse. It says use the horizontal line test. So, would this have an inverse? Yes, it would, because that horizontal line is crossing the graph in only one place. So this has inverse function. Okay. Are there any questions about number 15? Or are there any questions about what will be on exam number 2 on Tuesday?